Hi folks, Modelling Mark here again with a new project which is the Universal Pillar Tool. This is a kit sold by Hemingway Kits. First question, what is the Universal Pillar Tool? Well, it's one of those things that can be used for numerous things. You can build a sensitive drilling head for it. I'm not going to do that at the moment, I may do that in the future. You can use it for tapping. It's a very sensitive tapping tool. You can use it for rivet staking, numerous clock making uses for it. Not into clock making, so I won't be using it for that. You can use it for holding number punches and stamping dials very neatly. It's probably got a lot more uses that I can't think of at the moment. It's a bit like 1, 2, 3 blocks. You don't know how much you're going to use them until you actually get hold of them. I mean, I've got a set that I use almost every day. My brother's got a set of 1, 2, 3 blocks that are still in their wrappers. He's never used them. Anyway, that's enough waffle about the project. Here's a quick photo of what you get in the box. One thing to note is that you don't get any drawings in the box. So you will need the book Workshop Techniques by G.O.H. Thomas. Worth buying the book anyway, it's an interesting book, lots of useful stuff in it. There's also a partner book, obviously also by G.O.H. Thomas, called Model Engineer's Workshop Manual. Again, a very useful book. You can get these books new, they're quite expensive. I picked mine up second-hand off eBay, much cheaper than the new price. Let's make a start with the base casting. I'll put this in a 4-jaw chuck and lined it up on that top curve as best I can. Can't get it very close because it's a bit of a ropey casting, but that's about as good as I can get it. I spun the casting on low speed to give me a better idea, and it looks like it's running fairly true. I think it's as close as I'm going to get, so I can live with that. We'll start by putting a nice deep centre in the base of the casting, then I'm going to use a live centre to support it. We're going to be turning on the outside rims, there's going to be quite a lot of leverage, so a bit of support won't go amiss. Right, I'll clean up the base first. Now I'll get in as close as I can to the centre, but it's not going to matter that I can't get all the way in, because later I'm going to turn a recess into the middle of the base. I think that recess is a bit like the punt in the bottom of a wine bottle. It's mainly there to stop the base rocking. I'll turn down the edge now. The drawings give a dimension of a diameter of 3 3/4 inches. But it's not critical, so I'm just going to turn it down until the casting is cleaned up nicely. Now I'm just going to chamfer the edge of the base. This will reduce the amount of filing I need to make it look all nice and pretty. That's the majority of the machining done on this side of the base. Now I'll take the centre out of the way and I can machine off the bit of the base that I couldn't get to with the centre in the way, and then I'll machine the recess in the base. As you can see, I've just put a Sharpie mark to give me an idea of where the recess needs to finish. There is a dimension on the drawing, but obviously it's not a critical dimension, so I just put it out to somewhere close enough. Drawings give a dimension of 1/8 of an inch for the depth of the recess. Again, obviously it's not particularly critical, so I've gone to about 1/8. I wasn't too worried about getting it spot on. I've turned the casting round in the 4-jaw chuck now, and I've lined it up so that the bush of the top is running true. I've now got to bore out the hole for the column, and it's much more important that the column is central in that bush rather than worrying about the base running perfectly true. So now I'm just cleaning up the top of the casting, ready to bore out the hole. Now I'll clean up the edge of the top of the casting just to make it look nice. A bit more to go yet. That's just about there. There's no dimension for this part, it's just cleaning up the casting. Now I'll just round the corner a little bit with the file. Now the hole down the middle needs to be 7/8. So I'll start by obviously a centre drill, then drilling it out as far as I can with drills, and then finally I'll go in with the boring bar to take it out to a nice good sliding fit for a 7/8 bar. A final check with the ball gauge, and we'll call that one done. Now the book has drawings for a sort of single cotter pin that goes through there and will clamp the shaft as per the drawing. I'm going to change that slightly. I'm going to do a double cotter pin so it will clamp from both sides. Should give a tighter clamp, and it's also the method used for the clamping in the Quorn Mark III tool grinder kit, which I've got on order. So that's a good practice to see if my theories work. The Hemingway Kits Quorn grinder kit, they describe how to make double cotters, and they've got quite a complicated jig setup. Now I think there's an easier way of doing that, using the mill, fly cutter and a little bit of maths. So I need to find the centre of here, then with the base mounted like this, I need to find the offset, and that offset needs to be carefully calculated so that I get the maximum crossover between the two bars without impinging on the threads. So I need to find that centre, and I need to know what that number is. Then I will take a bit of brass bar. I'll use a fly cutter to cut out an arc, and that arc needs to match this curve exactly. So the fly cutter needs to be centered on the same offset between the center of that bar and the center of this bar. With a bit of careful use of the mill DRO, I should be able to do that. And then once I've got a complete arc cut, I can then split it in the middle with a slitting saw. That will give me the 1 or 2 millimeter gap that I need to allow it to close up. And then I can just put it in a collet and drill and tap it and skim it to length. At least that's the theory. The first thing I need to do is to make a plug which goes in here and also has a slightly larger diameter, but those two diameters have to be perfectly concentric, so I can indicate off the larger diameter to find the centre of this bore. And then I will leave that plug in there, so when I drill through there and the hole breaks through there, the plug will stop the inside of this hole chipping. That's the plan. Let's see if it works. I've got a piece of aluminium bar to make the plug. I'll start by facing it off, turning down the two diameters and then boring the hole out in the middle. I won't narrate this because it's all very straightforward turning. I'll just leave you to enjoy the machining. that'll do nicely. Now I've set the base up on an angle plate in the mill, and you can see it's bolted to the angle plate with the aluminium plug. And I've used a set square to make sure that the boss for the cotter pin is upright. Now I can use the edge finder to find the centre of the bore. As usual, I'm finding one edge then the other, and then I use the half function. I only get the tiniest, almost imperceptible kick on this side as the edge finder rests against the top of the casting. Now I can move the y-axis over by the offset between the two centres. To line up the x-axis, I just moved it over by eye till it looked central on the casting. Now I've just put a bit of brass bar in the chuck, that's 1/2 inch. It's the material that will be used for the cotter pins. That's just to make sure the position looks right on the casting. Now I can drill and ream this out to a 1/2 inch. Now I'll just check the fit with the 1/2 inch brass bar. And yes, that looks good. Right, here's the scallop that's been cut out of the plug. Here you can just about see where the 1/2 inch hole has broken through into the main bore. The last job to do on this casting is to drill the 3 mounting holes that will mount it onto its baseboard. I've bolted the casting onto the milling table. You can see there's a bit of sacrificial aluminium under the casting so I don't drill through into the milling table. And I've just put a bar through the cotter pin hole so I can get that lined up against a vice jaw so it's parallel to the x-axis on the milling table. Now I've zeroed the DRO on the centre of the bore. I edge found off the plug as I did before. Now I'm using the hole function on the DRO to place the 3 holes. I'll start by spot facing them with a milling cutter so I've got a flat face to drill from. Then I'll centre drill, drill and then finally countersink the holes. I used a long spotting drill to mark the centres. That's because the centre drill was too short and I couldn't get the chuck past the top of the casting. The mill did not sound happy during this operation, but I think it was because I was running the milling cutter a little bit too fast. And here's the completed base casting. I think it came out quite nicely. Now all I need to do is file off all the roughness and then it'll possibly get a fill and it'll get a coat of paint. Still don't know what colour to paint it. Any suggestions? Put them down in the comments. In the next video I'm going to tackle the cotter pins, and if I've got enough time I may also include the column as well. If you enjoyed the video, please click the like and subscribe. I really appreciate it. Thanks again. See you next time.